Today we're going to look at free fall, which is an extension of the acceleration and the equations of motion. We're going to study objects thrown upwards and dropped downwards. I'll give you some tips and tricks and we'll do some practice problems. So free fall is if you have something that is dropped. If we were in space or in a vacuum, you'll realize that all objects are dropped at the same rate. The gravity is the same, and gravity is minus 9.8 meters per second squared, or sometimes you can say 10 meters per second squared. I would suggest to stick with 9.8 in your exam, but just to keep things easy for me to do the calculations in the video, I will maybe just use 10 to help you out. An object thrown upwards acts in the same rate. What happens is you throw the object up, and what's happening as it's going up? Well, gravity is pulling it down, right? Gravity is also pulling it down all the time, so that'll be minus 10 meters per second squared. Everywhere in this motion, it'll be minus 10 meters per second squared. It doesn't matter where you are, gravity is the same. So keep that in mind. As it's going up to the top, it will slow down, stop, then speed up again. So the v at the top will be 0. Which makes sense, because even here, as soon as I drop them, the starting speed, v equals 0. The starting speed, vi, I can say. In this case, it's going up, stops at the top, and then comes back down again. Fun fact for you is if I have a speed here, let's say this is plus 5 at this point, at the exact same space on the other side, it will be minus 5. Same number, but opposite. This is the speed, meters per second. Meters per second. If this was 10, this will be minus 10. If I throw it upwards with 20, this will be coming back in the same spot, minus 20. There's a little fun fact there for you. So, if you drop an object or throw it downwards, the initial velocity will be negative as it's falling down. Acceleration is acting down, it will be negative. The object will speed up as the velocity is increasing until it reaches a maximum speed, then it hits the ground. So here's an example. A boy drops a stone off the edge of this cliff, 125 meters. Find the velocity when the stone hits the ground. Find the time required when it hits the ground. So there's two things. We only have one number, that's a problem. We need 3 numbers to solve any question on these. Luckily for you, there are 3 numbers. He drops it. Starting speed will be 0. And he's dropping, is falling down, and we know what's bringing him fall down is the acceleration due to gravity. So acceleration is minus 9.8, I will just say minus 10. So now, all of a sudden, I have 3 numbers I can solve. Here are my questions, not questions, the things I need and things I have. Remember, this is falling downwards, so we can use negative, or actually you'll find that if you put that into the formula, you will cancel the minuses and you'll get the speed. Either way, Vf squared equals Vi squared plus 2a, not x now because it's going up and down. Why? It doesn't matter. You can write x. It's okay. It's a displacement, so it doesn't matter whether you write x or y. This is the rule we're using because I cannot use the other 2 formulas that we learned in the previous lesson because they have a Vf and they have a t in them. We don't have time, so we cannot find it yet using those formulas. This is the only formula without a time. 0 squared plus 2 times minus 10 times minus 125 equals 2500. That's for v squared. To the v, square root, and you'll get 50. I wrote minus 50 because he's going downwards. That's the reason I wrote this minus. In case you end up getting a positive number, we know he is falling down. It's minus 50 meters per second, okay, as he's falling. Now that I know my Vf, I can find the time. I have my Vf now, which is going to be minus 50. I have my I have my x. I could choose another formula. Which formula can I use? I can start with the first formula, the easy one. Vf equals Vi plus At. My Vf was 50. My Vi was 0. A we know is negative 10. T is what we need to find. So I'll divide both sides by 10, and you will get, minus 10, sorry. Cancel the minuses and you'll have 50 divided by 10, you'll get 5. So that's a simple way to solve this rule here. Time is measured in seconds, so don't forget the unit for time. So as I've mentioned, constant downwards acceleration, it will slow down, stop, accelerate. It's always 9.8, even if it's thrown upwards. This is important in an exam, they'll try to trick you. So if the motion is only downwards, you can ignore all the minuses. If I'm only dropping an object, you can keep it as positive. As long as your numbers are the same, you'll get the right answer anyway. Something to know, like I mentioned, free fall, I throw it up and it comes back down, you'll realize that it's the same on either side. On either point in time, it ends up being the same speed, but obviously in the negative side. So that's everything that we have covered for this topic, and I think that should be okay for you. These are other ways that you can write the same formula. Instead of writing A, you might see it as minus G, because it's gravity, negative 10. Instead of writing X, it will be Y, negative X. So you can use that. So you can just change it around a little bit. You do not need to do this. You can if you like, but the rules are exactly the same as we did before. VF, and then you have the X VIT plus a half AT squared, exactly the same. I've just replaced with this. Here's another example. A ball is thrown vertically into the air, initial velocity of 20. What will the velocity be after 3 seconds? So thinking about our ideas here, we don't know the final height. I do know the starting speed though, it was 20, thrown upwards, so I will say positive 20, upwards is positive. Final speed, I do not know. Time is 3 seconds, and the acceleration is minus 9.8. This time I'm going to use 9.8. VF equals VI plus AT. You'll get VI 20 plus negative 9.8 multiplied by 3 will give you minus 29.4. And you will get negative 9.4, which means the ball is on its way down. It went up and then decided to come down. After 3 seconds, I am over here at minus 9.4 meters per second. Same idea in this question. You can see that the model rocket is launched upwards. Initial speed is 50. How high does he go and how long does it take? Again, we know the gravity is minus 9.8. So gravity is minus 9.8, but in this question we used 10, so I'll keep it back to 10 again. Sorry for jumping around. In this case, it is minus 10, because I can see that they've written that there. Okay, so you will do VF squared minus VI squared to GY. Remember, that's the same as to AX. All you need to do now is figure out the height. So we need to find Y. So VF was 0. VI is 50 squared. Minus 2 times 10, which is 20, because gravity is 10, so 2 times 10 is 20. And solve for Y. You will just do this, which is 2500, and then you're going to divide by 20, and you will get 125 meters. That's going to be the distance. If I wanted to find the time to reach the final height, I can use the first formula. VF equals VI plus AT. I'm going to replace it with minus GT just to show you that it's exactly the same. 50 minus 10 times the time. Rearranging 50 over 10 gives you 5 seconds. Okay, the final velocity in this case will be 0 because he reaches the final height and he stops. And it falls and then comes back to the ground afterwards. There are many more examples which I'm not going to go through to make the video too long, but you can check them all out yourself and you can see the solutions for them all. Okay, so ball's moving upwards, there's my peak, this is the displacement graph, and he comes down again. The speed, he's slowing down, stops, and then he goes into the negative side. He's coming down again, minus, 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 but getting faster in the minus side. This is this velocity graph. The acceleration graph is always negative. So this is what the graph would look like for something that is thrown upwards. Really important to know. Thank you.